यस आ गए क्या अनुराग जी? बच्चे 4-5 बच्चे ही है, सब ज्वाइन कर रहे हैं। अभी वहां से मुझे मैसेज आया था। अनुराग जी सुन पा रहे मुझे?
जी जी जी।
हाँ, अभी बच्चे ज्वाइन कर रहे हैं। वो थोड़ा सा वहाँ का लगता है नेटवर्क थोड़ा डाउन है, कुछ होगा, हैदराबाद है ना, वो इशू है।
नहीं, वहाँ तो नेटवर्क होना चाहिए।
नहीं, वो कैसा है अनुराग जी, वो मेन एरिया में नहीं है, थोड़ा
अच्छा।
आप समझ रहे हैं, थोड़ा सा उस एरिया में, इसीलिए थोड़ा देर हो रहा है। मैंने अभी मैसेज किया था उनको। एक मिनट अनुराग जी, मैं फोन करता हूँ उनको, ठीक है?
जी जी जी।
हेलो अनुराग जी, सुन पा रहे हैं मुझे?
जी जी जी।
मैं अभी फोन लगाता हूँ उनको, ठीक है? ओके। The first one who qualified for this NASA rover challenge, team for US under 19 team. So now it's time to request Anurag Behra ji, are you there? Hello?
Yes, sir.
You can start because children are sitting on projector, so we can go ahead.
Okay, sir.
You can see the numbers. You can see in the video also.
Yeah. So, hello all, and it's an honor to be part of this. And thanks for inviting IDYM Foundation, and thanks for having the NAPSAT team the part of this event. So, to all of you kids, first thing I would like to just say that always it has been told to us that space exploration has been always about finding life outside Earth. Is there life in Mars? How can we colonize on Moon? How can we how can we lead the normal life the way we lead in Earth in the same way in Mars? So that has been the way how we have always been taught about this. And every time we have been told that we need very hi-fi knowledge to pursue this. But in real sense, if you analyze, then space and things about space is also about making lives a lot easier on the Earth itself. Because today there is a satellite in the sky because of which we all are having this kind of session over the internet without any issues. I don't need to go to your state, but I'm still able to convey my message to you. In the same way, all of you during this lockdown were able to study from home because you all had access to internet, which was because of a satellite. Today, a cricket match is happening somewhere in Australia. You are seeing that in somewhere in Hyderabad. So definitely it's because there is a satellite. So a camera is recording the whole event and it is sending it to a ground station, and from that ground station it is going to a satellite is sending to a station to a station in your Hyderabad, and from the station it is going to your TV. So that's how you're watching a cricket match as well. So today, because of the satellites, you have this thing called as the Google Maps. Today you can put the coordinates today you can put the address of your friend in the phone and it shows you the shortest path through which you can go. This is all because there are certain satellites in the space. So space is not just about finding life, but it is also about making life easy. And so that's what we are going to talk about today. And we will talk about satellites briefly. So yeah, to start off, first question I would like to ask is, what is a satellite? We all might have known about satellites. Like there are satellites we see, like there is Aryabhatta satellite. There are different satellites which are launched by ISRO for different purposes. Certain satellites which are launched by NASA for different purposes. So, if possible, can any one of you answer what's a satellite? Sir, is it possible to get the answer from them verbally, or like should I continue?
Anuragji, yes, dear sir, can you just connect some student with the like mobile phone so that they can ask the answer the question asked by our scientist? Dear sir, is it possible? Hello. I think it is connected with projector, Anuragji, so it will be quite difficult. Yeah, their mic is off. Yes, please. I will call him on phone and then I will let him. Okay. Yes, Anuragji, please proceed.
Okay.
Hello.
So, yes, I am sharing my screen.
Yes.
So to start off, like, what is a satellite? A satellite is any object in space that orbits or circles around a bigger object. So these objects are basically celestial objects, the objects which are outside Earth in the space. So there are two kinds of satellites. One is natural satellite and one is artificial satellite. Natural satellites are the one who are present by default. So even your moon is a natural satellite because it is revolving around the Earth, but it is natural. It is existing by the nature. Artificial satellites are the satellites which we make and we send. So it is made by human, man-made. So natural satellites, we can't control them. We can't do anything much with them. But artificial satellites are the one which actually make the life a lot easier on Earth and also helps us to do a lot of space exploration and many other things. So what are the types of artificial satellites? So there are these are the types of artificial satellites. So the communication satellites, the artificial satellites that are devoted for the purpose of communication. So now when we are communicating, communication satellite, we are talking over phone. So the satellite which is actually helping us in doing this communication is communication satellite, remote sensing satellite. So what happens is in certain places, in certain remote locations of the Earth, we need to trace what is the amount of green coverage on the land, what are the rivers flowing through that area, what is the space available between two river streams in that particular area, so that we can use that for certain purposes. So all of those things are called as remote sensing. So the satellite that is used for this purpose is called remote sensing satellites. Then navigation satellite. This navigation satellite is the
Hello everyone, please mute your mic. Please mute your mic. Please only one mic at one time, because if you on two mics at the same time, there will be chances of echo. So please try to avoid that. Okay, you can on one mic at one time. Yes, Anuragji, please.
So navigation satellites are the satellites which actually help you to find out the location of a person, to find out the directions, like where you have to go. So these are the satellites who have the map. They show you the direction. Then is a geocentric satellite. So every satellite which revolves around taking the Earth as a center of the rotation, as the revolution. So these satellites fly at a different height from Earth. So based on their height ranges, they are divided into three parts: LEO, MEO, and HEO. And geostationary satellites are the satellites which throughout their lifetime stay on top of the same place. So like if you have deployed
Dear everyone, please don't unmute your audio. If you are unmuting, it is getting echo. So please try to avoid that. It is my humble request to all of you, because scientists are getting disturbed, when it is getting echoed. So please try to avoid that. Okay. Yes.
So like today, if you send a satellite to monitor all of Telangana, then throughout the lifetime, the geostationary satellite would stay on Telangana only. It will not maneuver to any other location. So if the, so basically the rotational speed of the earth and the revolutionary speed of the satellite, both these will be in same sync. So if earth rotates at this much speed, this also should rotate at the same speed. So that's how it will always stay on top of the place for which you have sent it. Drone satellite are the bodies which are at the height in which the satellites exist, but they are like, they can be controlled from the earth with remote, and they are currently used for many war based purposes, where you attack your enemies from the top where enemies can't identify, because you are at that height, so enemies can't identify you. Polar satellite are the one in which the satellite moves from the north pole to the south pole direction. So generally other satellites will move around the latitude of the earth's globe, but the polar satellite will move in longitudinal direction from north pole to south pole direction. Then comes the nanosatellites. The nanosatellites are the one who are very small. The size of the nanosatellite will be very small. It will be even less than the size of my fist, whatever I show. Cube satellite is comparatively little larger than the nanosatellite, but its shape will be like a cube. So when we talk about satellite, we always think about that that the body that is floating in the air is the satellite, but the whole of satellite is a big system. Only satellite itself can't do anything until and unless it doesn't have any connectivity with the earth. So the whole of satellite system is called as, is divided into two parts. One is a space segment, one is the earth segment. So the space segment is that part of the satellite which actually we think to be the real satellite, which is actually flying in the air or flying in space. But there is earth segment which is actually getting us the information from the satellite to the earth, and also sending certain commands to the satellite from the earth. So this is a basic photograph. So this is the whole satellite system. This is the space segment of the satellite. This is the earth segment of the satellite. So the space segment of the satellite has various parts. So there is a part which actually helps us to control the position of the satellite. So this is position and also height of the satellite. So this is called as altitude and orbit control subsystem. Then the unit using which we get the data in a remote location from the satellite, and we track the position. We track the position. Earlier we were controlling the position. Here we are tracking the position of the satellite, like where it is currently, and we are commanding different things to the satellite, like to capture the image at this instant, to monitor exactly this area, or to change the current position. We are just giving the command, and also we are monitoring the health of the satellite. So this segment is called as TTCMS. So telemetry, tracking, commanding subsystem. Then there is power and antenna subsystem. So power and antenna subsystem means power satellite is actually a piece that is floating in the space, but it has a lot of electronics because there are camera, there is antenna. All of them need power to run, right? They have electronic circuits inside them. So the system that actually provides them the power. So how generally a satellite gets the power? It gets the power from the sun. So we take the solar energy and we use it for distributing it among our circuits inside the satellite. So the system which is responsible for collecting the energy from the sun and also distributing it among the internal parts of the space segment of the satellite is called as the power subsystem. And antenna subsystem, as we know, antenna is the person through which we actually transmit or receive the data. So the subsystem which is controlling the antenna is actually called the antenna subsystem. Now transponder. Transponder is a system which is present between the antennas. So basically it is called transmit plus responder. So that's why it is transponder. So what is so it's like the satellite understands a particular signal in a certain way. The satellite again sends the signal in another way. So the way the earth segment of the satellite understands the signal and the way the antenna understands the signal are different. So transponder subsystems are the one transponder subsystems are the one who are actually responsible for making a link between these two different formats of the data. So the form in which we send a command to get a particular image from a particular forest to our satellite and the data that we get from the satellite to the Earth, both the data need to be translated. So basically, the captured image has to be transmitted into the format in which the antenna of the satellite can send it down, and also the format in which we send the information into the way how the satellite will understand the command. So that part is done by the transponder. Earth segment is the segment that is actually sending the signal to the satellite and also receiving the signal from the satellite. So that's the Earth segment. So whatever is there on the upper side in the satellite, which is actually floating in the sky, the same is also there. The copy of it is there on the Earth, but on the reverse side. So basically, whatever you send from the Earth can be received in the satellite. Whatever the satellite sends can be received in the Earth, and from the Earth it goes to different places how it can be reused. So this is a high level diagram, but I don't think for your age group this is significant. So like to the conclusion, satellites have actually now grown in purposes, and today because of growing technology around the globe, the satellites are actually part of our lives more than we know. And these satellites are also helping us to read different parts of the space, and also today satellites are helping us to find out locations, find out people, find out better restaurants around us. So it's a whole new world after the satellites have become more and more easier. So earlier, to pursue this space technology, it was very difficult because first thing, the information was not available this easily. But now there are so many organizations around, and the information is so easily available in Google. So in this era, you and your generation is the first one which is actually going to pursue this and practice this technology in the mainstream very easily, because earlier if anyone pursued this technology, they only had to go to NASA, only had to go to ISRO to display their skills. But now if you consider, then you have many private companies, many other small organizations who are working for it, many people who can help you gain knowledge for it. So this technology is now getting easier. So your generation will be the first one to implement it in a large scale. Now slowly satellites are coming up for agriculture, for mapping of life in water, in some ocean, slowly. But actually, your generation will be the one who will see a lot of satellites in the sky for different personalized purposes, which will make the lives very easier. Now there is an upcoming technology in which we will not need more of the telephone tower. Only your phone headset should be sufficient to communicate, even to have internet. And that is because just a satellite will be handling it. So that's how a satellite is making our lives easier. So with this, I would just like to say all of you that never think that this is out of reach. I always need to be a very great student. I always have to be a Stephen Hawking to pursue space technology. No, everyone can do it. It's just you have to decide that you want to do it, take the step towards it, and on the way you have to learn. So basically, today if you are making an electrical circuit to light a light bulb, it's not that you learn everything about a copper wire and you learn everything about what is the plastic that is making the insulator for the wire. No, what you need to do is what all you need for making the circuit to light the light bulb. So you need to get those components, and then while making the circuit, you get to learn about everything. That why is that plastic insulator? Why is the copper a conductor? Why is the switch? Why switch in this position is conducting? And how should I fit the switch so that it is easy for everyone to switch it on? So that's how you learn. If you try to learn everything in advance, then you don't even know how you are applying it. Then how can you learn it properly? So never think anything to be out of reach. Now everything is in reach. All you need to do is think, and think big. Never think that I can't do it. Always think that we can do it. That's how the students of our organizations tried. And then they are the first ever under 19 interdisciplinary team to get selected for the NASA Space Human Rover Challenge. And first time in the 50 years history of the whole of NASA, any under 19 interdisciplinary team that has got selected, and that too from India. So these kids who are studying in class 9th to 12th, they are going to represent India soon in NASA. So if they can do it, you guys also can do it. So thanks for your patient hearing. Then I would like to request Kanuri Varshini, who is one of our students. So she shall share her experience and more with you all. Thank you. Thank you for your patient hearing.
Thank you, sir. So, hello everyone. I am Varshini, the STEM lead of Team NAPSAT, the Bhunesh Prasad Student Astronomy team. So first of all, before starting anything about the project we are working on and other more things, I'll just give a brief about our organization, because you have been listening to our mentor and we, so you should have a basic knowledge about what we are. So NAPSAT stands for Navunmesh Prasad Student Astronomy Team, which is a great incentive taken by the Navunmesh Prasad Foundation under the great thinking of its leaders, Mr. Anil Pradhan and Ms. Vaishali Sharma. So basically, this entire organization was set up to instill curiosity, develop skills within students like us, students like me, students like you. First of all, for doing anything, we need to have the skills. So the main aim of this entire project was to develop the skills to to do something like some research or experiments. So the main aim was to develop the skills and to instill the curiosity that how can we use these skills in the utmost, the best manner, to instill curiosity and to develop skills within the school and university going students. So yeah. So currently, this thing goes on with the triple E technique of NAPSAT. So what is this triple E? EEE stands for experiment, environment, and experience. So let me just share a fact with you. So the first day we go to our school, right? A teacher comes into the class and she starts taking the book out, turns over the pages, and whatever it is given in the book, she starts teaching us. Likewise, from our very small age till our 10th, 12th, and after that also, we get a syllabus. We get a syllabus. So yeah, I think there was a network issue.
I think she
So
has got
yeah.
disconnected. Yes, next. Yeah, please. Please.
Yes. So from our very small age, we get to learn whatever our teacher teaches in our school. So we never think that there is something else different from whatever which is given in our books. But what happens in NAPSET is whenever we see our books, our teacher tells us that water cycle. Okay, water cycle is what we learn in our books, right? Water cycle up, it forms the clouds, clouds condense, and it forms the rain. We have never really experienced it, right? Have we ever seen that? Okay, water is being evaporated, it forms the clouds, then the rainfall. We just have read it in our books, right? But NAPSET is where you can just experience everything. So first of all,
I think she is facing some network problem. Any one of you else can continue, if possible. Hello.
oh, sir, I'm continuing it myself.
Yeah, please, dear, please.
So NAPSAT is a place where you do the experiments by yourself. First of all, you do the experiments. Then it's not necessary that you do it right in your first attempt. You do it, you get the wrong result. Then you do it again, get the wrong result. But much more times you get it wrong, you get to experience. Okay, what is the thing that I'm doing wrong? And from that comes the experience. Okay, so after that, after you do a lot of wrong mistakes and all in your experiments, then the teachers or the mentors will provide you the perfect solution. Like, this is the environment or this is the particular condition in which you need to do the experiment so that you can get it right. And that is called, after that, you get to experience. Okay, this is the way that we should do it right. But what happens in our schools is that we read a chapter, we read a lesson throughout the year, and at the last, we give the test. But NAPSAT, you need to do the test and then you learn a lesson from it. So as Anurag sir has already told, that when we started with this organization, there were 10 people who were going to NASA from but we didn't stop with the thought that it is we who should learn, but we thought that it is we all who should learn. So that's why we have been reaching out to you and more people like you. So there are two projects currently. One is NASA HERC that we are a part of, NASA Human Exploration Rover Challenge, in which we are building a vehicle, which I'll be showing you shortly. And the second is CANSAT 1.0, in which the students are building a CAN-sized satellite. So in this entire project, the main mission is to spread the word of innovation within the blood of every student of the world. So not wasting much time, I'll just show you the project we are working on, like the main vehicle or the rover we are working on. Okay, so let me just share the screen.
Yes, so children's try to listen to her. She is doing. They are doing a really a great work. Only 10 members teams are there, but they are doing a tremendous work. So all of you try to get inspired by them, and try to do something which is not done in your life. Try to learn from these people and do it by yourself. Yes. Yeah. So this is what message they are trying to give it to all of you. So take it positively. Work hard. Work smart. We are there to help all of you. We don't charge any money for anything. We'll just help all of you to become a superstar of the world. Yes, Karuna. Yeah, please.
Okay, so can I ask you guys how the video was? Am I audible?
Yes, you're
You are
audible, but
audible. Yes,
somehow
you
your
can carry on. You can
voice
carry
is.
on, dear. You can carry on. I can hear you. Yes.
Okay, so
Okay, so children, so you have seen that is a NASA rover. That is a NASA rover. You might have seen in the TV a few days back. There was a rover was successfully landed by NASA on Mars. So this is the same thing which is will this student will represent in coming April month up to 2021. Yes. Are you connected out here?
yes.
Varshini, you can
So
switch off your video if
so
your net bandwidth is less.
okay, sir. So, so this is called a rover. So let me tell you what a rover is. Rover is a sort of vehicle which the astronauts they use to travel in the extraterrestrial planets. That means to in the other planets when the astronauts they want to conduct some experiments or they want to go and explore the various planets. So this is the vehicle that they use. So here I think you can see the two seats and the two astronauts will be sitting in the opposite sides and they'll be pedaling it. So this is the pedaling system where through which they'll be pedaling the rover and like they'll be moving to different parts of the planet and they'll be. So I'll tell you a basic of these parts of the rover. So this triangular shape material, I think you can see this structure. It is called the mainframe of the rover. So what is the mainframe? So it is a structure which supports the different parts of the rover. So like the car is there, layman language if you tell. So there is a basic structure with this metal where all the other engine parts or the wheels, everything is attached. So in the rover, mainframe is such a part where other parts like the wheels, the seats, the pedals, everything is attached to this mainframe. So you can see that here we have taken the mainframe in in the triangular structure. So the question may arise in your mind, like why we took the triangular structure? Why not some cuboidal or trapezoidal? It would have been like you will study that the triangular structure is the most strongest geometrical figure because whenever the some load is given, so load I can say that some force is given. Suppose the seats are here and if some people the drivers board drivers will sit here and some pressure or some force will be exerted here, so when the pressure of the force is exerted here it will be equally distributed to both the sides and thus this triangular framework is the most strongest geometrical figure. So next moving on to the other parts. Yeah. So this is the wheel structure. So this is the simple wheel, like we ride the cycle every day, right? So this is the simple same structure as that of the cycle. So like in our cycle, we see that there are spokes. The spokes are present, but here in the rover, metal plate is used. So this metal plate has been plasma cutted, and this is the plate which used instead of the spokes in a rover. So the plate has been used to increase the strength of the wheel. So this is the tire. So like we all know that the tire, the same tire as that is present in the cycle, and this is the rim. The rim is the steel material that connects the tire and this plate, as same as that of the cycle. So next, this is the seating system. So in the rover, that there will be two astronauts present who will be sitting in these two seats, and they'll be riding the rover to move to different parts. So this is the very simple structure, and this is like a knapsack's modification in this seating assembly. That is the middle part where you can see the logo is present. This is made up of a cloth. So this cloth has been chosen according to, like, with all the measurements and calculations. So that providing that it has considered amount of strength. This cloth has been chosen, and here the astronauts will be sitting. Yeah, so this is the plate, this is the tire, and this is the rim. So this is called the suspension system. So suspension system means the system which connects this wheel to the main frame. That means, like, suppose in a car, you see that the wheel is present and the main body of the car is there. So suspension system is a system which connects the wheel to the main parts majorly which are present. First one is the wheel which which moves, rotates. This is the hub. Hub means the part which connects the wheel with another structure called knuckle. Okay, so knuckle is the part which helps in changing the direction of the rover. So like we have seen in the car, that in our car the steering is there. So if we rotate the steering in either right or the left side, the car moves in the direction. So how do you think that the car moves here and there? So when we move the steering, so in our rover, that's steering. So like same as in the car, whenever the steering is turned, the knuckle also turns, and in turn this turns the wheel, and we can change the direction of the rover. So this is called the suspension system. So yeah, so this is the entire rover. So I think this is like enough, because this, like the technical, I won't tell you more about